So my topic today it was on the automated testing and failed continuous integration attempts that I try to do with the website. So I was going to kind of describe what automated testing was in general and continuous integration was in general in the specific context of what I was trying to do. So kind of the context was this is how the development on the website works. You have a developer who does some stuff locally. They go and submit eventually when they're happy with it, they go and submit their code to the GitHub repo, which is just a repository where all the code sits. And then we go someday right now it's just kind of when I decide that it's ready to be updated, I go SSH into the Hills server and go git clone the GitHub repo with the website code in there, and then that's how an update to the website happens. And that's really cool so far. But then we start getting more people in the project. Now we have 4, yeah! So now we have like 3, let's say there's 3 developers, and we're all contributing different code, right? We're all working on different features, different branches. We're doing each our own thing. We're each developing the part of the website we hate the most. But then one day, developer B in this case, goes and submits bad code. What is bad code? Bad code would make the website fail, like something like getting a 404 error, or like it just looks terrible, or maybe not looks terrible. That's too it's not quite what automated testing would prevent, but it's code that would cause an error page to show, or something just isn't right, or it's missing a critical feature. But they go and submit that code, and then time passes. So everyone's just been building on top of a bug, basically, that's been in the code base. Somewhere down, let's say there's like 20 commits down, was this bug was introduced and no one caught it. Let's say it even works on developer B's own computer. It looks good on their computer, but no one else has taken the time to be like, wait, this doesn't actually work on their own computer. So when then I go and I'm like, all right, time to update the Coders Club website. So I SSH in and I go and pull down the website. Well, now we've just pulled down a bug into the working copy of the website, and now everyone, all 10,000 visitors we get a day, and I'm sure that's how many people will go and look at our website, are going to go to this website and find this bug. That's not good. And if you can imagine in a more serious project, that would be even worse. Can you imagine like going to google.com and getting a 404 error? Like, what the hell? So the problem is the bad code. Let's say the bug was even something that worked on all of the developers' computers, but when it went into the production environment on the actual web server, it didn't work. I mean, you could go and sit and blame the web server and say Hills is a bad server, but really it was ultimately the programmers who made the bug, and they made the bad code. So a solution to this problem, in this context that I've made up, is automated testing. And so what comes kind of with that is test-driven development. So automated testing is the idea. Automated testing is the idea that you want to prevent, in this kind of scenario, you want to prevent developer B from ever having submitted bad code. So the way you would do that is write tests for your code. So let's say you want the website to behave a certain way, you would write tests that ensure that if the website was working correctly, this would be true, that would be true, if this, then that. And then every time a developer wishes to go submit code, they would go, well, wait, let me run the test. Oh, all the tests passed? All right, that guarantees to me that this should work. If the tests are good, my code should work. Here's my proof, not like, oh, no, it works, bro, don't worry about it. No, like, here's proof. Then I submit it, and then you would, ideally, if the tests are good, you would never get this kind of scenario. So I thought that was really cool. And I really like that idea. So I went and actually did it. So right now, on the Coders Club GitHub repo, and actually right now, this is my personal fork of the GitHub repo. So this is where I'm contributing all of my code. And so I'm developing locally, and I'll go and submit code to my fork. And I use this program called Travis CI, which is really freaking cool. It's this website where you can go and log in with your GitHub profile. It's free if you have an open source project, which the website is. And you go and configure Travis CI and GitHub to kind of listen to each other. So I've set up Travis CI so that every time I push my code changes to GitHub, Travis CI will pull down those code changes and run my tests for me, and then tell me whether all my tests passed or all of them didn't, and what exactly happened. So, and that's really powerful. I don't even have to run my test. I don't even have to think. I just go, oh, I'm done coding. I'm going to go to bed. Travis CI will do the work of running the test for me and telling me if they failed or not. And so what that kind of looks like is really nice. So what you see here is this is my own little Travis CI space. And you can see the GitHub repo that I'm working under. My username is possibly, I'm working on the CCSF Coders website. And this is the most current push that I've made to the repo, to my own little fork. And you can see here exactly what Travis CI is doing. It basically just, this might go over some people's heads, but the idea is that it just spins up a little virtual machine, and then you configure it. You can see exactly what my configurations were for this new machine, exactly how I told the test to be ran. And then you can see here, this is what the test looked like. I wrote the test in Python, and I'll show you what that looks like in a second. But you can see here, test meeting info is present, blah, 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 is okay. Test social media links are present. There's an error, so I go and I look down here, big ol' error in this test, and I can see, it's a little bad, I need to write some better tests, but no such element exception, unable to locate element social Twitter. So we can see here that in my, I wrote a test to make sure that we had all of the social media links, including Twitter, and right now on the website we actually don't. So my tests, I made some changes. We don't have Twitter on our social media links. The tests fail. I'm immediately notified, and I know exactly what to fix. So it's really nice. And so that's something that I spent some time on. I actually also built the tests, which I was kind of excited about. The tests were pretty nifty. This is them. It's only one file. It's maybe 60, 70 lines long. I used Python. I like Python. And I used something called Selenium to simulate a browser. So what's kind of nifty about this, I would run it, but it takes a little bit more than a minute to undo some changes I made. But the idea is that what's actually happening on Travis CI, because of the way I configured it, is it actually is going and cloning the repository, starting up an Apache server, starting up the Apache server with all my configurations with PHP 5 installed, and then simulating user clicking on the website and simulating, actually opening up a browser, looking at the website as it is and seeing oh, is this element there? Is this element there? Click on this, click on this. So it's actually as if there's a little human in a box going through and clicking stuff. So it's kind of nice. And so that's something I was working on for a while, and now I not only have it on my fork, but I also have it on the actual CCSF Coders fork as well, which is really cool. So now every time that anyone submits code to the Coders Club repo for that website, they will be notified if it sucks. And what's kind of cool about that is actually, if we go to the organization, one of my little favorite things is really goofy. But actually on the repo, I edited the README to have a little image. So now we can see anyone on the website, they can go see if our Travis CI build is failing. And right now it is. But soon that'll be fixed because Ian's going to add the Twitter link. So hopefully we'll have build passing, which will be really nice. So that's what I've done so far. And kind of to wrap up my talk, was this idea of continuous integration, because I hadn't gotten to that part yet. And this was actually a fail story because the idea behind continuous integration is that you have all the developers pushing to the GitHub repo. You go, the pushes, your code that you've changed goes from the GitHub repo to Travis CI. Travis CI goes, oh, build passing, you're good to go. And then actually, if a build is passing, push it right to production. Just go and update the website automatically. Don't make Tyler one day have to go clone the repo. And so that would be super sweet. And I actually got pretty far in configuring it and then ran into a problem with Hills because at some point you actually need to have the incoming request from GitHub. GitHub says, hey, Coders Club website, update, git clone, go update the website. And Hills is like, what the hell? I don't trust you. So you actually can't do that, unfortunately. Or at least I couldn't figure out a hack to get around it. And so that was what I've been working on. Thanks for listening.